Okay, hello and welcome back. This video is going to cover section 2.3 on applications of linear equations. So this video and the next couple videos will all be around applications of the skills we learned in the last couple of videos around solving linear equations in one variable. So we'll get to apply them. And so that means that this will involve looking at word problems, which can be pretty tricky. But if you can get a good method down on how to solve these, it's really going to help you out in a lot of different classes like chemistry, biology. A lot of any of the like math questions in a science class end up being word problems like this. And then also it can be beneficial in your regular day-to-day life too. So let's take a look at a few examples. So the first subsection here is on solving problems involving general quantities. So let's look at this first one. So it's asking us to write an equation and then solve. So as I read through, and this is just part of my general strategy for solving word problems, I'm going to read through and I'm going to I can highlight on here, but maybe if you're looking at it on a piece of paper, you can like underline or circle words. I usually go through and I start to highlight things that seem important because our first task will be translating from the word problem into some kind of equation that will be able to solve algebraically. So let's take a look. So this question says, swimmers Michael Phelps and Katie Ledecky both competed in the 2012 Olympics in London and in the 2016 Olympics in Rio de Janeiro, where they won a total of 18 medals. So I'm already going to highlight that. Usually if they mention some kind of a total, that's going to be important. Something is going to be equal to 18, usually like the sum of all of the separate things. Then they say Phelps won 6 more medals than Ledecky. I hope I'm pronouncing that last name correctly. And then what is the question asking us to do? It says, how many Olympic medals did each athlete win? So that's ultimately how we're going to need to answer the question. So I think the textbook has like a specific series of steps that they follow. I'll just show you my general method. And the goal is just to come up with a method to solve these. So regardless of what the specifics of the problem are, we'll be able to work our way through and get to what the question is asking for. So the first step is generally to say what our variable is going to be representing. And you can use X or Y or any letter that you work with, but let's just say, let's let X equal the number of medals that are won by Ledecky. So number of medals won by Ledecky. So I'm writing this down like for my own good of like remembering what I'm saying that X represents, because it can sometimes be easy to lose track midway through. So now notice it says Phelps won 6 more medals than Ledecky. So how could we represent that in terms of X? Well, if X is the number of medals won by Ledecky and Phelps won 6 more, then X plus 6 would be the number of medals won by Phelps. Yeah, I think Phelps was one of the most decorated Olympians of all time. So yeah, this is like a translation. We can say number of medals won by Phelps is equal to 6 more than the number that Ledecky won. Okay, so we know that the total, altogether they won 18 medals. So we can set up a little equation. We know the number of medals won by the number of medals won by Ledecky plus the number of medals won by Phelps, and we're describing that as x plus 6. So they're both described in terms of x. If we add these two together, it should equal 18. 18 medals. So again, this was Ledecky. This quantity is for Phelps. And then this is our total. So let's just solve it like an equation. Got some like terms. X plus x will equal 2x. So 2x plus 6 equals 18. Then I'll subtract the 6 from both sides. So 2x is equal to 12. 18 minus 6. Then I will divide both sides by 2. So then 12 divided by 2 is 6. So x should equal 6. But we don't want to stop there. We need to answer the question in terms of the word problem. Like, what is the problem looking for? It's looking for how many Olympic medals did each athlete win. So let's state it. We know x is the number of medals won by Ledecky. We just found that x is equal to 6. So we can say this swimmer won 6 medals. And then we had said that Phelps won 6 more, or x plus 6. So since x is 6, 6 plus 6 is 12. So we can say Phelps won 12 medals. And that will be our answer. So I just want to answer in terms of the context of the problem. So in general, I would start by defining some variable. Well, I guess technically we start by reading the question and maybe picking out or highlighting things that seem important. Then label a variable, because we'll need to work with some variable. The variable represents one of the unknowns, or the unknown from the question. Then we can translate the problem into some kind of equation. Then we need to solve the equation and then state our solution in terms of what the question is asking. So maybe we call reading the question step 0, but probably the most important step. All right, let's see another example. So this is example 2. Again, it says write an equation and then solve. So it starts off saying, Nick has half as many songs on his playlist than Mariah. And then together they have a total of 4,887 songs. Notice that together is like a total. It's usually on one side of the equal sign. And then what is the question asking? How many songs does each of them have? So we have Nick as an unknown and Mariah as an unknown. And notice they describe Nick's number of songs like in relation to Mariah. Nick has half as many songs on his playlist as Mariah. That's sort of like in our last question, they described the number of medals that Phelps made. It said Phelps won 6 more medals than Ledecky. So if they're describing one unknown in relation to the other, it's usually the other one that I set as our variable. Like I said, Ledecky was x because we're describing Phelps in terms of that unknown, which we haven't found yet. So I'm going to use that same idea here. It says Nick has half as many songs on his playlist as Mariah. So I'm going to let my variable, we'll say let x equal to the number of songs that Mariah has. So number of songs, I'll just say for Mariah. Oops. Okay, then it says Nick has half as many songs as Mariah. So if we take that X, number of Mariah's songs, and divide it by 2, that would be half as many. So X divided by 2 is the number of songs for Nick. All right, so and we know also that together they have 4,887 songs. So let's do something similar to our last problem. We have number of songs that Mariah has, which is X, plus the number of songs that Nick has, which is X divided by 2. And we add them together. We should get 4,887. Now we have an equation in one variable involving a fraction as well. So we can either work on combining these two fractions or maybe clearing out the fractions, and we played around with that a bit in some previous videos. I think I'm going to combine these two fractions together. So in order to do that, and I say two fractions because we can view this as like an x over 1. And to do that, we need a common denominator. So I have 2 over here. If I multiply this 1 by 2, I will turn it into a 2. So I'm going to multiply this left fraction by 2 over 2. So that will give me 2x over 2 plus x over 2, still equal to 4,887. Now that they have the same denominator, I can combine them together. So 2x plus 1x is 3x. And when adding fractions, you don't add the denominators, you just need to make sure that they're equal to each other, and then it stays the same. So 3x over 2 equals 4,887. All right, so now I am going to multiply this 2 over to the other side, multiply both sides by 2. So I'll be left with 3x on the left side. Make a little more room. And then 4,887 times 2, you should get 9,774. Then I have 3 times x, so I will divide both sides by 3. You'll cancel the 3's on the left side. So you should get that x is equal to 3,258 after dividing that big number by 3. So if x equals this number, and this was the number of songs for Mariah, let's find out how many songs Nick has. We just take this number and divide it by 2. So 3,258 divided by 2, you should get 1,629. All right, so let's just state our solution in terms of the problem. It wants to know how many songs does each of them have. We said X was Mariah's, so we'll list those first. We can say Mariah has 3,258 songs. And then Nick has half as many, so we divided that by 2, and we got the 1,629. And then if we wanted to check, we can add these two together and just make sure that they sum up to 4,887. All right, the next subsection has us looking at lengths. So we're going to solve problems involving some kind of unknown lengths. And this happens a lot if you're trying to build something or trying to fit something into some space. You have to solve some unknown lengths. So let's take a look. It says a plumber has a section of PVC pipe that is 12 feet long. It's like a total length. He needs to cut it into 2 pieces so that one piece is 2 feet shorter than the other. And then it's asking us, how long will each piece be? Well, we might be able to just think about this and come up with a solution, but oftentimes it's a bit harder just to read it and see it. So the thing I would always suggest is just to try to draw a picture. It doesn't have to be perfect, like to proportion. As long as we understand what we're representing, it will be useful. We just need to label it carefully. So let's imagine that we have this section of PVC. And we know that it is 12 feet long, this total piece before we cut it. That's like what you're going to buy from the store. So one large piece. And we want to cut it into 2 pieces. It says one piece is 2 feet shorter than the other. So there's one longer piece and some shorter piece. So maybe something like that. So we can say this longer piece is some unknown length. I'll just call it x, so that would be this length here. And then if the smaller piece is 2 feet shorter than this, than the longer piece, well then this should just be x minus 2. 2 feet shorter than that longer one. So I'll just write out what I'm doing. I'm going to say let x equal the length of the longer piece. So x minus 2 is the length of the shorter piece. And we know that they should add up to 12. So it's almost like the question with the metals or whatever. We're just applying it to a different kind of idea. So we know they should sum to 12 feet. So I can write a little equation. The shorter piece plus 2 feet less than that shorter piece. That's the second piece. Or I'm sorry, the longer piece. So the longer piece and then 2 feet shorter than the longer piece. Add these two together and the sum should be 12 feet. So let's solve it. We have x plus x, so that will give us 2x minus 2 equals 12. Then 2 is being subtracted, so I'll add 2 to both sides. So 2x equals 14. Then let's divide both sides by 2. Since it's being multiplied, it'll cancel on the left side. And 14 divided by 2 is 7. So x equals 7. But again, don't want to stop there. Let's answer in terms of the problem. So this x was this longer piece. So one piece is 7 feet. And we are in feet, right? Yeah. So one piece is 7 feet. And then the second piece was 2 feet shorter than that. So 7 minus 2 is 5. That'll be our second piece. The other piece is 5 feet. And those are our 2 pieces. Kind of a simple example, but you can imagine it can get more complex. So I'd always recommend just trying to draw a rough little sketch. Even if it's not super perfect or beautiful, it's really for your own, just to help you visualize what's going on. And that's always helpful for me. All right. This last subsection is on what's called consecutive integer problems, and these can seem a little strange, but I'll show you my style of solving these. So by consecutive integer, well, what does consecutive mean? It means like one after another. It's like the next one. So for instance, like 3, 4, 5, those are consecutive integers. Integers are whole numbers. And notice that you just add 1 to get to the next one. So we'll use that as we build our solution here. So let's look at this example, example 4. It says, the sum of 3 consecutive integers is 87. Find the integers. So we have the sum, meaning that we're going to add them together. So it can feel weird on where to start here, but let's just say x is our first integer. Like if we had 3, 4, and 5, the sum of those would be 12, so that's not ours, but we're calling our first one x. And then to get to the next one, you add 1 to it. And then to get to the next one, well, you would add 2 to the original number, since you're like 2 slots away, 2 locations away. So let's use that fact when we're building this equation. We have our first integer, then the next one, well, that would just be x plus 1. One more. And then the one after that, well, we would add another one here, so it'd be like x plus 1 plus 1. We can just write that as x plus 2. So it's like 2 away from the initial integer. So this is the sum of 3 consecutive integers, and this should be equal to 87. So now we have an equation in one variable. Let's just clean it up, combine like terms, and solve for x. So this is like saying x plus 1 plus x plus 2 equals 87. So it looks like we have 3 x's, x plus x plus x. So that would be 3x, and then we have 2 plus 1, so 2 plus 1 is 3. So 3x plus 3 equals 87, just combining like terms. And then since 3 is multiplied by x, well, actually first let's move this plus 3 over. We'll move it as a minus. So these will cancel. So I'll get 3x equals 84, 87 minus 3. And then now, since 3 is multiplied by x, I'm going to divide both sides by 3. So now these will cancel. And I get x equals 84 divided by 3 is 28. So 28 is our first of these consecutive integers. So it must be 28, 29, and 30. So I'll say 3 consecutive integers are 28, 29, and 30. And if you add those up, you should get 87. That's how you can check. All right, let's look at example 5. This one might be a little bit more tricky. So instead of consecutive integers, now we're saying specifically the sum of 2 consecutive odd integers. So the odd part is what's going to make this a little bit different. So the sum of 2 consecutive odd integers is 19 more than 5 times the larger integer. What a messy statement. So let's write some stuff out, and hopefully it'll become easier to see how this question is set up. First, let's think about what they mean by consecutive odd integers. What are the odd numbers? Well, that's like 1, 3, 5, 7, and so on. So notice this time, instead of adding 1 for each time, you add 2. 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7. So you just need to add 2 to, if you're starting at an odd integer, you just need to add 2 to get to the next odd integer. So if we're saying the sum of 2 consecutive odd integers, well, we would start with our first one, x, call that our first odd integer. So then the next one would be whatever that number is plus 2, x plus 2. So that's our sum of 2 consecutive odd integers. And they're saying this is, the is typically your hint to put an equal sign, is equal to. Sometimes they just say is. Now, the second statement says 19 more than 5 times the larger integer. Well, the larger integer is going to be this one that's 2 more than our starting point. This is what we're calling the larger integer. So 19 more than 5 times. The 19 more means that we would be adding 19. But I'm going to first start with the 5 times the larger integer. Well, if our larger integer is this x plus 2, 5 times that, we would just want to multiply it by 5. So 5 times the larger integer, and we want 19 more than that. 19 more than 5 times. So I just need to add 19. A lot of times the wording is feels a little bit flipped, or like the equation is sort of like backwards from the wording, which is an interesting thing. So let me just read through again and see if this makes sense. The sum of 2 consecutive odd integers, so some odd integer, and then if I add 2, I get the next one, okay, is 19 more than 5 times the larger integer. So this looks like it's set up. So we've converted the word problem into an equation. Now we just need to solve. So where should we start? First I want to clear the parentheses, so I will distribute this 5 into each term. And then on the left side we can just drop those parentheses. So we have x plus x plus 2. 5 times x is 5x. 5 times 2 is 10. And then we still have the plus 19. On the left side, we have x plus x, so that will be 2x plus 2. And then on the right side, we have 10 plus 19, so that should give us 29, positive 29. Okay, we can move our x's over to the left or the right side. I'll move it over to the left side this time, so I'll subtract 5x from both sides. Since it's positive here, to move it over, I would need to subtract. So minus 5x. 2x minus 5x, that would give us a negative 3x plus 2. These cancel here, and I'm left with positive 29. Now I will subtract this 2 over. So I get that negative 3x equals 29 minus 2. That should be 27. Then I just need to divide both sides by negative 3. So 27 divided by 3 is 9, and since I'm dividing by a negative, positive divided by a negative, the result will be negative 9. So we can start with a negative number. The integers include the negatives as well, just negative whole numbers, both positive and negative. So we can say, I'll answer in terms of the problem. The integers are, starting with -9, and in the next consecutive integer, we said we would add 2 to it, so -9 plus 2 is -7. You're like $9 in debt, and then you deposit $2 into your account. So now you're less in debt. It becomes less negative. And that will be our answer. So these can be a little bit tricky with the wording because I'm not really used to speaking in this way. But a lot of problems in like other kinds of applications and other classes end up kind of being in this sort of form, just with a more specific context. This is a little bit more general. So for these, if it's just consecutive integers, then the next one will be just one more than the previous one. If it's consecutive odd, then it would be 2 away from the previous one. So you would have to add 2. And this would be true also if they were consecutive even integers. To get to, say if you have 2, to get to the next even integer, which is 4, you would need to add 2 as well. So keep an eye out for this odd or even detail in the questions. That'll help you see where to move forward from there. Okay, this video was on section 2.3. This is our first application of linear equations. So we solved problems involving general quantities, we solved problems involving lengths, and then we finished off by solving consecutive integer problems. All right, that's it for this video, and we'll see you next time.